Yes, so it's Hangout on Air. Welcome to the session on opportunities and threats of digital fabrication for 3D for project management. Now, if you go here, you can watch this online on this live now on YouTube as well as on Google Plus. So let me welcome Fernandao and Dr.Greshan and Dr. Buddhika Jayasena again. Now maybe we can start directly. Greshan, if you can start first introducing yourself and going ahead with your presentation, you can do so now. Yes, Greshan.
Yeah. Thank you, Chaminda, and good evening and good morning to some of you. And I'm joining you, and I'm Fernandao, and joining you from Seattle, United States. I mean, can you hear me? Hello?
Yeah, I keep my mic muted, but you can go ahead. You can hear, we can hear you very well.
Yeah, okay, good. Just making sure. Okay, so currently I'm working as a process engineer for the Boeing company, and usually I work on computer design and computer manufacturing process development. And recently I started working on the process development side of the 3D printing, or in other words, digital manufacturing as well. So, you know, in addition to my experience at Boeing company, I have worked as a professor here in West Virginia University in the past, and at that time I gained a lot of interest in this 3D printing and
we can't hear you again, Greshan.
Yes,
we can't hear you.
oh, sorry,
Something happened to your audio. Check again. Buddhika, can you see if there are any problems? You communicate. I have to take care here. So Buddhika can communicate to Greshan. Greshan, we can't hear you. Or maybe something wrong with our.
Sure, but I can hear you him very well.
Do you hear me now?
Yes, Greshan, I can hear you. Yes.
No, I think there's a problem with our speakers. Hold on.
Okay. Yeah, let me know once you can hear.
You can hold now.
Okay, sure. Maybe you should stop the live streaming until you get it fixed.
Yes, now you can go ahead. Greshan, go ahead.
Okay. All right. So I'll directly jump to the presentation now. I'm going to share my screen with some PowerPoint slides, and then I'll be talking to those slides. And if you get any questions, just hold that thought, and then ask that question at the end of my presentation. And I'm going to take about 15 to 20 minutes for the presentation. So let me share my screen and then get it started. Chaminda, do you see me? I mean, see my screen?
Yes, go ahead.
Okay. So my topic today is the incoming third industrial revolution and digital manufacturing. Digital manufacturing, in other words, the role of digital manufacturing within this third industrial revolution. So, Chaminda, did you see my slide changed?
Yes.
Okay. So, do you see my like major economic drivers in a society? That slide?
Yes.
Okay, great. Okay. So usually, when you look at any society, there are three major economic drivers. So one is energy, and the other one is the transportation mechanism, and the other one is the communication mechanism. Now, all these three are required to produce any products or services. Now, when you look at the history, we had two industrial revolutions, and those two industrial revolutions took place around the three economic drivers. So when you look at the first industrial revolution, the that energy source was coal, and then the transportation mechanism was the steam powered locomotives, and then the communication mechanism was the printing press. Now, when it came to the second industrial revolution, the energy source was replaced by oil. There's still some coal in the mix as well, but major energy source became oil, and then the transportation mechanism became not the locomotive, but the internal combustion engine and all the automobiles that are driven by the that are powered by the internal combustion engine. And then the communication mechanism became the telephone. Now, today we are seeing, we can experience another industrial revolution slowly emerging, and we already see some major drivers within that third industrial revolution. In the next slide, I am going to talk about that this incoming third industrial revolution, which is again happening around those three major economic drivers. So, as you can see here in this slide, the energy source in the third industrial revolution is going to be green energy. That means the energy produced through solar energy and wind power and other green energy sources like hydroelectric and wave energy and so on. Then the transportation mechanism is becoming the electrically driven automobiles, and then the communication medium has become internet, just like the way that I am talking to you today. A lot of people are communicating through the internet today. Now, in addition to all these three economic drivers, there is a new platform emerging called the Internet of Things. What it does is it integrates all the economic drivers and all the physical devices in the world into a single network. Now, when we have that capability, when we have that integration, we will gain a lot of. When we have that capability, we gain a lot of. We gain access to many things that we didn't have in the past. Now, also, in the third industrial revolution, the product and services will be manufactured through digital manufacturing technology. And I'll talk about the digital manufacturing in the next slide. But in the past, we use a lot of conventional manufacturing technologies to produce these products and services that are required to drive the economic activity in a society. Now, with the digital manufacturing technologies, our way of manufacturing things are going to be, so in other words, are being changed, to a new new way of producing things. So let me in the next slide, I'm briefly talking about the digital modeling and fabrication. So basically, digital modeling means creating a computer model of a physical object that exactly replicate that physical object. So today there are a lot of computer design software to build digital models. And in addition to that, we can also build a digital model using an existing physical object by using scanners. Now, when we have a digital model, then we can manufacture that the object in the digital model by using digital fabrication technologies. So basically, a digital fabrication is a type of manufacturing process where the machine used to fabricate that part is controlled by a computer. So as you see here in this picture, we have a digital model in the computer, and then we have a digitally controlled machine. Now that machine could be a computer numerical control machine, or a laser cutter, or water jet cutter, or a 3D printer. I think you saw a 3D printer in operation earlier. So with that 3D printer, you could end up with the physical part at the end, and you start with the computer model and then send it to the 3D printer, and then you end up with the physical object as you see here in this picture. So now this digital manufacturing technology has a lot of potential. So as you see here, I have listed some of those. So basically, it can trigger innovation worldwide. As if you think about those two industrial revolutions I mentioned earlier, the lot of manufacturing activity was based on these developed countries. Developing countries like Sri Lanka or India did not do much product manufacturing with those two industrial revolutions. Now with the third industrial revolution, it's going to change, because we will get the developing nations will gain the capabilities to manufacture anything using these digital manufacturing technologies. So basically, it will provide opportunities for everybody towards prosperity, and also it will contribute to the improvement of product accuracy, and it will reduce mistakes that are happening with the conventional techniques, and then we gain greater flexibility to customize the products. Or in other words, we can move towards something called personal fabrication. I mean, we will have the opportunity in the future to fabricate many things by ourselves, and also it will accelerate time to produce, and it will also reduce product cost. In other words, actually, it will reduce the marginal cost of producing things. And then, of course, it will improve collaboration globally, like we are doing today. You'll hear about the FabLanka project that we have involved with, and where we are collaborating globally to bring digital technologies to Sri Lanka. And there are many other capabilities that we gain through the digital manufacturing. And also it will, my last point is this technology could save this planet, and also it will contribute to save your life through digital printing of human body organs and other medical procedure, helping with other medical procedures like prosthetic legs. Now, as I mentioned, digital manufacturing is not just 3D printing, but 3D printing is the most advanced and new 3D printing technology. And with the 3D printing technology, you gain a lot of capabilities, especially to manufacture complex objects. As you see here in this picture, all these objects that are shown in this picture has been manufactured using 3D printing. You can see a varying range of products here in this picture, starting with a car, and then a house, and then a bicycle, very exotic lampshades, and a drone, and statue, and also garments. So, when you think about manufacturing all these things that you see here in this picture, with the conventional techniques, those are very challenging.
Greshan, you have to go a little faster.
Okay.
Yeah, you're sitting time. Thank you.
Okay. So with the 3D printing, we can produce all these products at a very faster rate and much easy and very easily. So as I mentioned earlier, this Internet of Things that I mentioned earlier, so it will enable this localized digital fabrication that includes 3D printing, and it will also enable the localized green energy production and distribution of that green energy globally. And then it will provide you the lot of data, or in other words, we call it big data and data analytic tools to everyone. And then it'll provide you new education mechanisms, like the way we are communicating today in this particular class. We can see new mode of education in the future, and also there are some new mechanisms that are in place right now. And then it'll of course facilitate global knowledge sharing and collaboration like we are doing right now. And also it enables something called systems engineering with the holistic view. That means we can see the entire world with a lot of data, and then use the system engineering tools to produce better systems and solve many pressing problems in the future. Now let's look at the opportunities and challenges to project management that are coming from this Internet of Things. So mainly in terms of opportunities for project management, Internet of Things provide a massive amount of information and a huge knowledge base. So that is very helpful, because that can be used for a lot of decision making, and always having more information is good for making any decision. And then it will provide a management of a very advanced project within small collaborative commons. That means, like, collaborative commons mean small non-profit or even profit organizations, but small scale ones that are collaborating globally. And in other words, you will hear about the FabLanka later, and the FabLanka is a collaborative commons, so a project that we are going to collaborate globally. And then also IoT will provide easy and real-time communication around the world. And there are many other opportunities I have not listed here, but those are some major ones. And then there are a lot of challenges as well, because there will be new tools to learn, of course, by the project managers. So if you don't learn those, then you will end up with inadequate skills and inadequate knowledge about the new tools. And also, since we are collaborating globally with the Internet of Things, there will be an increased number of stakeholders to manage. Of course, that's going to be a challenge in project management. Also, sometimes you may face with difficulties in communicating around the world, because now we have like a global village to work with. So then you are faced with some communication difficulties, especially if the people are not speaking English. And then with the new technologies, always people are expecting expectations are high, so you have to manage those high expectations, which is always a challenge. So those are some of the challenges, and there are other challenges, of course, but you can think of some, and then we can discuss if you have any questions. Now, with that, I'm going to briefly mention about this FabLab or FabLanka project that we have started in Sri Lanka, which I'm not going to talk about in detail, and then actually Buddhika is going to talk about FabLab in the next talk. So with that, I'm going to end here, and if you have any questions, I think we can field those questions at the end of all the presentations, I guess. Is that good?
Okay, thank you very much, Greshan. Buddhika, go ahead, please.
Good evening, everyone. Can you hear me?
Yes, sir. Go ahead. Yes, sir. Go ahead.
All right. Good evening, everyone. So it's a great pleasure to join with you all at this moment, especially to share the thoughts and ideas about FabLab and also new technologies in manufacturing. I'm Buddhika Jayasena. I graduated from Faculty of Engineering, University of Peradeniya as a production engineer. Later, I obtained my master's degree in computer integrated manufacturing and my PhD in mechanical engineering from Nanyang Technological University in Singapore. So currently, I'm working as a research engineer at Georgia Institute of Technology, Atlanta in USA. Georgia
Buddhika,
Tech?
sorry.
Yes.
I said to the students, because they are project management MBA guys, so
Okay.
I said that you were my MBA project management student 2005. So it's great to have you after 11 years as a resource person in another project management class for MBA. Okay, go ahead.
All right. So as I said, I'm working in Georgia Tech, and Georgia Tech is one of the best research institute in the world right now. All right. You have already heard about digital manufacturing, and also you heard the buzzword called FabLanka and also FabLabs. So let's see what is a FabLab. So now I'm going to share a presentation with you all. So let's see how it works. Give me one moment. Can you see this presentation now?
Yes, sir.
Is it clear?
Yes.
All right. So let's see what is a FabLab. Now previously Greshan talked about digital manufacturing. So FabLab is one way to implement this digital manufacturing. So basically FabLab is a technical prototype platform, that is kind of a support platform that encourages innovation and invention. So this FabLab started as a community outreach program in MIT, especially in US, and Professor Neil Greenfield is the head of this effort. So basically FabLab is a place to play, to learn, and to invent. It is a place where ideas and innovation happens. The drive is how to make almost anything using these FabLabs. So in a FabLab, basically the whole product development and designing process is taken place. Especially in this figure, you can see that some schematic diagram of product designing. So for an example, let's say that if you have an idea in your mind, so you can go to these FabLabs and you can implement it. Sometimes it can be a very novel idea. Sometimes maybe just you want to make a prototype. So basically this is a place where you can go and implement your ideas. So let's move into the next slide. So hopefully you can see that the FabLab environment. So this is a typical FabLab environment. It comprises of off-the-shelf industrial grade fabrication and electronic tools. If you focus a little bit here, you can see 3D printers and also CNC routers and also laser cutters and some kind of computer facilities.
No, we don't see you are moving. Your slide is not moving. Go to the next slide manually. You last time also had the same problem.
So how about now?
Suggested. Okay.
Yes.
Now, yeah. Okay.
Yeah. Okay. I got it. Okay. So this is the typical FabLab environment. As I said, there are a number of equipment here. Like you can see 3D printers, CNC routers, and some of the software tools. FabLab is equipped with tools for every aspect of technology development process. As I said earlier, for designing, fabrication, testing, and debugging, even for documentation. So we expect that every site or FabLab find a different subset of tools for most critical needs. Basically, they can customize these tools based on their needs and requirements. Ultimate goal of the FabLab is to make possible for the users to use the tools in the FabLab and make the next generation of tools that required for their needs. So that's why we use a FabLab. So let's see what are the characteristics of this FabLab. So the most important thing, probably you might already got that, it is open to the public access. That means it is freely open to the public, regardless of the age or the background. Also, FabLabs can connect with other FabLab charters and even with global FabLab network. When you use this kind of environment, you have key responsibilities. So what is the most important thing? The safety is the most.
You have to go to the next slide.
No, I'm in the same slide and I'm just speaking.
Okay, sorry.
Right. So the most important aspect is the safety. So as I said, it is open to the public, and you have to use all the safety precautions whenever you use FabLab facilities and also the processors. As I said earlier, the users should assist with cleaning, maintaining, and improve the FabLab. So this is a peer learning environment. That means you learn from each other. And apart from general public, so this kind of facility can used by other commercial institutes for activities such as prototyping or even incubating startups. So now I will move into the other slide, third slide. Hopefully you can see that. So there are several core values in this FabLab. As I mentioned earlier, the experimentation is the most important thing. That means if you have an idea, this is a place to go and try it out. So hands-on learning. Regardless of your background, these FabLabs are not only meant for engineers or scientists. It is for general public. So you can go and learn these equipments. And also you can try out them. So as I said earlier, it's open access. And also you can collaborate. As I said, FabLabs are connected with all around the world. So there are many people who try to solve the same problem. So you can connect with them. For an example, let's say that you want to make some component and it has been already made in somewhere else. So you have drawings on that, and you can download these drawings and you can use 3D printing type of technologies and you can print it out. And also empowerment, creativity are the core values in this FabLab. So these FabLabs are already spread around the world. Now there are at least 600 FabLabs all around the world. So you can see in this map how these FabLabs are scattered around the world. So especially in United States now, there are many more FabLabs than it is shown here. There are some very good examples. So here I have highlighted some of them. in Ghana, these Fab Labs, actually general community, use these Fab Labs to make their agricultural tools. In Norway, again, people use these Fab Labs to make radio colors and track their animals. These Fab Labs were located in the very remote areas. Even in Boston, USA, they use recycled materials to produce toys and craft. Ultimately, now it can become a business for them. So in this slide, you can see some of the projects implemented by one of the Fab Labs in UK. So if you focus a little bit on this slide, you can see digital painting, and also in the far right corner, you can see somebody built a boat with one sheet of plywood, and also in the last image, you can see that t-shirt printing in a FabLab facility. So that means if you have any idea, if you have a very innovative idea, you can go into this kind of FabLab and you can implement it. So in the next slide, now you can see, as I mentioned earlier, this is not only for engineers or scientists, this is for everyone. So in this example, one of the FabLab was formed in a liberal art college. So it says 3D printers, they use 3D printers and laser cutters. So there are enough examples like this. So basically in this project, through FabLanka, we want to transfer these technologies to the Sri Lankan community especially. So in this slide, so I'm trying to discuss some of the experience that I have got, especially in Georgia Tech. So as a university, we have something called Innovation Lab. So in this lab, same set of equipments are available, and it is open to the especially the students. Student means not only university students, it is open to the school students. So I have seen that they are coming into these labs and they are using these equipments. Not only that, so when I am attending international conferences, I have seen that there are a number of industry exhibitions, and recently there are a lot of 3D printed parts. So especially in this slide, I have attended one international conference in 2015, and I observed that there was a 3D printing case where they use this 3D printing technology to customize foods. So it was a very interesting presentation. Not only that, there are a lot of webinars and also presentations available in the internet. So now internet has been one of the major medium to discuss these technologies. So basically with FabLab, so what is the key idea? The whole idea is in this FabLab to improve the quality of the life. So that means we should help ourselves. With that, I'm going to conclude this presentation. Thank you.
Thank you very much, Buddhika. We had some kind of breakings in between, but the audio was clear. So thank you very much. Now let's go to Dr. Richard from Berlin. Dr. Richard, you are on the screen now, on YouTube also. If you can hear me, talk to me. We don't hear you. You might try again. No, we don't hear you. I see you, but I think you have to set on the settings. The settings, maybe you changed. Let me share my screen. Who's speaking there? Greshan, huh?
Yeah, this is Greshan. I see he is muted, so maybe you can unmute him, Dr.
I think I can't unmute him. I can only mute him. Okay, Richard, you have to unmute yourself. Go to the center of your screen, top center. There's an unmute button after invite people button. You are muted, yes. It's in the screen. You don't have to remove the headphone. In the screen, center, top, there's an option called mute microphone, unmute microphone. Can somebody type, please? Asking him to unmute. Richard, I can mute you, but I can't unmute you. Richard, in the screen, in the center of your screen, you have an option to unmute your mic. You are muted.
Hello.
Let me call him and check. So people who are in the first Skype, like for example, Richard is Skype guy. Now
I've unmuted.
Ah, yes, yes. Where are you? Oh, no, hold on.
I'm there.
Yes, yes. Go ahead. Let's go.
Okay, you can hear me. So I don't know what it is. It's the first time that you tried it.
Yeah, now it's
Everybody
fine.
can hear me. Then I will go on the presentation, on the slides.
Yes. You know how to share your screen, no?
Yes, I will share my screen.
Yes. And he is very happy to connect with us as his first video Google Hangout conference.
Yes, it's the first time that I do this. Now I share the screen. Bildschirmfreigabe.
Warten bitte.
Thank you very much already for your patience. So
these are patient. They are many people, so they are patient people.
Okay.
We can't see the screen. Can you unshare and?
I've done this. Maybe the connection is not. We have this.
No, this is okay. Again, in your left side. Left side. Vertical option, blue color.
It's a green color.
Yes, green color. Then you share the screen, and then you select which screen you want to share, and say share.
Yes.
And then click on.
Yeah.
So, now, for example, I have shared my screen with you, Skype screen. So I say stop.
Now it's your.
Yeah.
It's good now. I can see.
It's.
Yeah. Yes. Go ahead.
Can you get me now?
Yes. Yes.
Okay. Thank you very much. And I'm very pleased that the speaker before me explained everything about FabLab, so I can explain what I'm doing here. I'm a physicist and 3D artist, and hopefully I want to talk a little bit about biography. I studied physics at the University of Bayreuth. It's a small city in the south of Germany, in Bavaria. I studied also for 1 year in Grenoble, France. with a scholarship from the DRD. It's exactly the same scholarship where also Chaminda had from Germany. Then I made a PhD in nuclear fusion on microwave reflectometry. I worked for 5 years with Siemens Company in the R&D division, and for 5.5 years in the railroad division. And since 14 years, I'm self-employed. And since August 2015, I'm with R&D Center FabLab in Berlin. Here you see my academic background. Already in school, I made some work on the solution of the heat equation. Can you see this? Okay, I must. Explain that I started out as a physicist and then went on to other areas. Just to show you what I started in physics. It's a very long time ago, and it was done. At that time I worked on a project to calculate the propagation of heat in a solid state. I do not want to go into the details, just to show you what I have done, that I am a physicist and I have worked with such formulas and also with such structures. And it's quite similar to modern internet, where you have also many bodies and propagation of things. I do not want to bore you with this anymore. Okay? Then with maybe what's more interesting for you. Can you hear me? Yes, okay, fine. Then my diploma work I have done in X-ray scattering on molecular crystals. My PhD I have done in microwave measurements of fusion device. So during all my career as physicist, I've been working measurement systems. And then maybe what's interesting for you, as you are in project management, with the Siemens Company, the big German electronics company, I have been working for 11 years and mainly on speed measurement, contactless speed measurements. I will open one of my papers here. What we have done there, I just show you one of the pictures. We developed a radar system for measuring the speed of a train without contacts. So normally you measure the speed in a car or in a train via the wheel movement. So when the wheel is moving, you see how fast you are moving. And sometimes you have slippage and you cannot measure the speed of your system. And therefore, what you can do, you can mount radar sensors beneath the train, and by Doppler effect, then you have a measure of the movement of the train. They have been working for first in Munich in the Central Research Division, where we have been more implicated in developing the radar sensors. These are these microwave modules. And then later on in Berlin here, the implementation, making algorithms, extracting speed measurements out of these diagrams. So I think it's a little bit far away from 3D printing, but I just want to show you where I come from, what I have done earlier. Then after that, I had an idea what can be done with a flatbed scanner. It's also some time ago, and I found out this one. This is a principle how a flatbed scanner will take images. If you put objects at different lateral positions on the scanner, you get different viewing angles, and then you have a 3D. I do not want to go into details, but the thing is, I developed a procedure for taking 3D images by means of a flatbed scanner. Okay, I will go on. There I get a patent. I made a lot of applications. So the thing is, 3D is a very large field, and you have different type of scanners. You have different types of 3D printing, and I invented a very specific procedure for taking 3D images, and I got very much into the details. And what I found out, just here I want to show you. This is a prototype model of the scanner. You have the flatbed scanner and lateral transition, lateral movement, and then you can automate this process. I want to show you here.
So he's sharing a video, so we can watch the video when he's showing the screen.
I don't know.
Yeah, it's coming. It's good, but you have to manage your time, huh? You already.
Do you have it? Yes.
Yeah, yeah.
So maybe I want to summarize. I worked a lot in physics and then found out that you can take 3D. Maybe we switch it off the sound. And what you see here is that you have different viewing angles. Look at this box, and this is the basis for 3D images. So what I'm working on is 3D image and not 3D models with a printer. What one could do, one could take these different images, go into software and make a 3D model and then print it.
Yes.
Okay.
Yeah. Can go to the next one.
Here you see my pictures, which I presented. So what I have done after having worked for many years in research and industry, I developed these 3D art, if you want to say, based on a patent. So I've always been working for a long time at the intersection of technology and creativity.
So this is your house?
And this is, you mean this one?
No, that's Queen Rania from Jordan. I love her.
Yeah, exactly. Now we are coming back to the presentation which we had before. So when you're working as physicists and as 3D artists, I thought, where can you go on? What can you do with areas where you have been working? So, and an ideal place is FabLab. And now we come to the former presentation. So, and also in FabLab you have a lot of creative people and you have also engineers. It's exactly the environment for that. And this, some months ago, it was the Jordanian Queen who visited Berlin FabLab, and the photo was taken just with my gummy bears. I mean, you see this picture? This is one of my best pictures I've done in 3D. I was trying to show you one here. Okay, with this one. Actually, this picture, this gummy bears, is the best one, and they gave it as birthday present to the boss of Haribo, the company who makes these gummy bears.
Gummy bears means?
I don't know whether gummy bears are. Pardon?
What is gummy bear means? Bread something? Burger. Okay. 3D printed burger?
It doesn't video.
It doesn't move, but we see the screen.
It doesn't move. Maybe okay. Then we skip it. I mean.
Yeah, we see the nice lady only, the announcer, and not the old guy.
Yeah. So it was. Yeah, I just wanted to show you this because it has been on television. Yeah. Okay, then we take the other one.
Yeah.
Presenting you FabLab in Berlin.
Yeah.
me met outside FabLab here. There's maybe a bad connection.
We can't believe when you're in Germany you have a bad connection. That is not an excusable thing. We are connected with 4G. Yeah, bad connection.
It should show it now as
Yeah,
it would. Oh no, now it works.
So this was taken when I visited FabLab in Berlin, where I met Dr. Richard. So we actually met by accident.
Yes, and this is exactly the same room where I'm sitting now. Here I have the 3D printers and all the other machinery around me, and this is exactly the creative environment I've been speaking of. I mean, for me as a physicist, it was very interesting coming back in an environment where you have a lot of machines and tools where you can, where we are again closer to. This is a big printer here, the wrap which is behind me, and you have really good exchange. When you sit here, people will come, talk to you, yeah, then you exchange. And on the other side, you have the R&D center, where I have my desk, and where it's more quiet, where you can do solid work, and here it's more kind of an exchange.
So these items actually from FabLab, there, Berlin. These are done by normal people.
It's a preliminary architecture. They are going to replace it in 1.5 years, but it's nevertheless it's good architecture. Here you have the different labs where people are working in. So
that's me. Don't look at my belly, huh? It's the wrong T-shirt. I met him there. You can continue, huh?
It was there that we connected.
Video get stuck.
And this is the exactly the open environment you have here. People meet and talk to each other, and then we exchanged email. I found this video on the internet, and what I then found is that Chaminda had the same scholarship than me from the German Academic Exchange Service, and so we really connected then.
Okay, we can go to the next one.
This is
So FabLab is not only 3D printing, the scanners, lasers, cutters, and then you know, it's an open space where innovators, people in the community meet. Yes, sir, go ahead.
So okay, and then what I have done in the last, I've been here only for 6 months, and I have a friend, and she wrote a book about FabLab, and so I asked her to present her book here in FabLab. This is what she did by the end of last year, and everybody who wants to know more about FabLabs, I really recommend this book. It's in English, and there are 10 or 15 authors having written their perspective about FabLabs, more from the movement point of view, more from the technical point of view, with different contributions. And this is, when you write down the author, I think it's a good recommendation. So, and now to my person, as I explained you, I worked a lot in physics. What do you want to, what I do in FabLab? I mean, and then I'm very glad that the speaker before me laid out what FabLab means. So I personally, as a physicist, made a 3D invention, made 3D art, and then I studied the sales process. And what I expect from FabLab is to reintroduce more technology and newer technology into what I have done as an artist. And this is really the environment I found here. And it's also for me personally, you find here people from different streams, you find engineers, you find physicists. So my professional way has been from Max Planck Institute, having done really science. Then I went to Siemens. There I made R&D, Siemens in Berlin, or product implementation. Then I have been self-employed for a long time. And here in FabLab, I find an environment where to reconnect all this. Thank you very much for your attention.
Okay, Richard, thank you very much. So we have Greshan, Buddhika, and Richard presented their different ideas and different experience. We talked about digital fabrication, Internet of Things, and then what is a FabLab, and then Richard explained about personal experience. Now I would like to you to ask questions before we. I think since we kind of lost time, now it's almost 7:20, so we can ask some questions from them when they are connected, and then we can close the session, and we'll have a small break, and we come back to the Priyantha's discussion and follow-up discussion on our other assignments. So I think I suggest that you can ask some questions. Maybe I can repeat. They don't hear. You can also ask directly. But it's not end. We have a FabLab, what we do in Sri Lanka. Priyantha will explain that. But you are free to get your clarifications, doubts, and also talk to them. They will be very happy to hear your voices. Any questions? Yes, sir. As Richard and others, you should know that our guys are so diplomatic. They take some time to organize their questions, but I allow them today. Maybe Richard, if you can show around in your FabLab, the background, if you can.
Yeah, you mean me walking around and showing the FabLab?
Yeah,
did I understand? Yeah. Yes, I will do this.
But you have to unshare your screen first. Yes.
Okay, yes, I will do this.
You have learned Google Hangout very quickly, huh?
Yeah, I mean, it's the first time that I have done this, and I think I must exercise a little bit still. Oh, you see me now. I can go around FabLab. We will do this. Yes. Try this.
And what is the time in Germany now? 2 o'clock. Oh.
Do you see me? Do you see the?
Yes. Yes.
This?
Why no people there?
This is. But yeah, people here.
Okay. So you are in office.
Yes. This is the way you walked in summer.
So this is something like what we want to have in Sri Lanka.
Here's the kind of conference area. We have curtains. You can remove the curtains. You see?
So this is winter, no? What is the temperature outside?
What's our temperature? It's about minus or so. And here you have snow.
Yeah, after a long time it's so snow. Okay.
Yeah.
And
our FabLab is very close connected to Otto Bock Metal Company, run by Otto Bock Company, and you see the building. This is this medical company where FabLab will move in 1.5 years.
Okay, great.
And you can also open the curtains, and you have the whole space.
Okay, meantime, please ask your questions or comments or anything.
Yeah, sure.
Three guys. Show your knowledge to my visitors. Don't disappoint me. If I did this presentation in India, everybody will be asking questions. Come on. Greshan, Buddhika, are you there?
Yes, we are there.
I think we had more questions from 18 years old from in Virul Vikramashila Central College, A-level students. Any questions or comments? No questions? You want to ask any questions? Greshan, Buddhika, Richard, from my guys? Maybe they are fasting or something to do. Intellectually fasting. Any questions?
So
Greshan,
I would like, I would like to ask a question from them, like whether they have heard about additive manufacturing, digital manufacturing, or even about 3D printing before.
I think last time when I asked the question, there some people said yes,
Okay.
but only one or two guys have like a physical experience before today. To around out of 50 people, yeah. But
All right.
Some two have. What is the experience you have?
I saw one in Singapore, but what I would like to know is whether what are the ways if we want to do some sort of, especially with related to healthcare. So if we want to get some artificial limb manufactured or something, whether how can we get the prototype or there are any software we can use?
Okay. So we have a doctor in our class. You're working for the ministry, no? He is interested to know in terms of health sectors. Now, what are the? Did you hear the question? Artificial. So how to do that? Or what are the possibilities? Software.
So how can we get the?
Greshan?
Yeah. Yeah, there are free software, and also, you know, it is a very complicated one, and we, you know, I have access to a lot of commercially powerful software as well, but you know, free software like FreeCAD and you know, OpenCAD. OpenCAD is only 2D, but the FreeCAD is the 3D you know, design software that you can download and you know, use right away. You don't need it. You don't need to pay any money to use FreeCAD. And FreeCAD is, you know, pretty powerful. You can model, you know, almost anything. There are few limitations, but I don't think that will hit those limitations with the application. But in case if you need help with the you know, more complex part, then I can help with the designing here and sending the model. So we can provide you like an evaluation copy of the software until you get the job done. So yeah, we have a lot of capabilities in that you know,
Yes.
in that area.
So there are a lot of free software available. You can download and directly use. Or if there are more complex ones, we can also help you to work. Richard, you want to say something? Yeah, Buddhika,
Can I add something here? Can I add something here?
Yes, sir.
Yes. If you're thinking about the finished product.
Okay.
If you think, okay.
Yes. Thinking about the.
Okay.
Okay, he knows about that. Go ahead.
Okay. If you want to start a project, let's say that you want to select one amputated person in Sri Lanka, and if you want to do something, there are certain companies do free service at this moment. So in USA there are a couple of companies. So if you're really interested, you can start something like that. So you can do two at the beginning, but you can start some kind of a project.
Okay, thank you.
Yeah, I think you want to model first. So if it is the modeling, you have software, but then if you need the, you know, final product, that again, you know, once we have the model, you can you know, manufacture it here, and there are a lot of ways to get that done. Again, we can help with that as well.
Okay, any more questions? Comments?
In this presentation, the use of building of the documents.
Yes.
Is a type of a
What is the question?
As we use do the food processing out of this?
Okay, so
For using a jelly or
yeah, so maybe I think anybody can answer, but Richard, you are the one who showed that. So about food printing, is it happening? And
Food printing. Yes, I have heard. I recently spoke to a woman, and she making chocolates and all this, and they started with food printing. But I do not have the results. They said it's no problem working in food. I mean, there are a lot of people making designed foods, but this is in an experimental state. I do not know a place where you can go, and so I will print it like in Star Trek. This is not reality now.
but
If I add something, in the research scale, yes, there are institutions like National University of Singapore. They are doing a lot of research on this, on food printing, especially chocolate and biscuits. That's what they want to print, and they want to test it.
Okay. Any more questions, ladies? We just heard that you can print jewelry with gold, 18 karat gold and 14 karat gold. One of our colleagues sent the company link. More questions?
How long will it take to operationalize this?
Okay, so maybe this is a general question. Now, how long it take, maybe in years, to commercialize such applications? Or what are the challenges of doing that?
So the food already, I mean, in the US there are small scale manufacturers that are using 3D printers to print chocolate and sometimes cakes. So it's already commercialized, but not in a mass scale. And then in terms of heavily commercialized areas are the aerospace and automobile industry, where they use 3D printers to make especially the complicated parts in cars and airplanes and jet engines.
Okay, if you can just tell me, like at Boeing Corporation, what kind of direct applications you have?
So at Boeing, 3D printers are used to especially manufacture this some of the components, like customize seats and also a lot of interior parts, like the parts that you find in the galleys and laboratories. And then the General Electric is using 3D printing mainly for very complex jet engine parts. So, and then also Boeing is the process of using the 3D printers and providing a digital library of parts to the airline customers, so that they can print the spare parts by themselves. Like for example, if Sri Lankan airline has Boeing airplane, then they don't have to order part, but they can print it once they have a 3D printer. And Boeing is going to make all the designs available to them, so that it's going to be proprietary of course, but then they can print it, and they're going to charge the people using their digital library. And that's another heavily commercialized application.
That means we will see airlines or carriers like Sri Lankan Airlines, Emirates, Qatar Airways will have 3D printers, and they will print their own parts of Airbus or Boeing, in time to come.
Yes.
Actually,
it's already.
Yeah, go ahead.
Yeah, it's already. Yeah, they are building the digital library right now at Boeing.
Okay. Okay. Any questions from the ladies? No ladies here. Okay, thank you very much. So we are going to take the break. Now after the break, we will go with Priyantha's presentation. You have option, Greshan, Buddhika, and Richard to be online, or you can go now.
Actually, I'm going to.
Okay, so I will stop the broadcasting, and but.